Hey everybody, this is Mrs. Musoff, and I'm going to run through the Day 2 notes with you through this video. Alright, hopefully you've got your note sheet out, and you can kind of follow along and write down any questions you might have to ask me tomorrow. Okay, now this warm-up, I would like you to take a second and try it on your own. So pause the video, see how much of it you can figure out. Remember, just watching me do it's not super helpful. It's more important that you try something, figure out where you're going wrong so that you can fix it for later. So pause the video. I'll wait. Pause it. Alright, when you're ready to go, you'll unpause it. Pause. Alright, well, here are your answers. Hopefully you tried it on your own before checking out my answers. Vertex form, again, you could look at your notes if you need to, but hopefully remembering the A, the H, and the K. And then when you're given an equation, this is vertex form. Alright, so you should know the vertex right off the bat. Now, how could I figure out it's a max or a min? That's based on whether there's a reflection, which comes from the number right here. Alright, there's no number there, or rather it's a positive 1. Positive means it's going to look like a normal parabola, and that means facing up, so there's a minimum. Okay, now, the increasing, decreasing, you might have wanted to draw a picture, because that would be a tough one to do in your head. So that's why I drew my picture over here on the right. And that kind of helped me to figure out which way it was decreasing versus increasing. Alright, well, that's just a little review on what we did yesterday. Hopefully that stuff is making sense. Because today we're going to move on and we're going to be talking about the other two forms that we should be able to graph a quadratic in. That's intercept form and standard form. Alright, intercept form, like the name suggests, means you should be able to find the x-intercepts just from looking at the equation, right, without a calculator if I needed you to. So intercept form looks something like this. Y equals A, still has the same A, times x minus p times x minus q. So I don't know if maybe this form looks a little bit familiar, because another name we call this form is factored form. Because in order to write something in intercept form, you would need to factor a quadratic. We're going to be doing factoring in the next few days, so if that sounds familiar at all to you, that's awesome. If not, no big deal, we'll review it. Okay, but in intercept form, you're going to have two separate factors, and those are going to tell you your x-intercepts. So here, my x-intercepts are going to be p and q. So the point p comma 0 and the point q comma 0. And notice how these have minus signs in them? Kind of like how vertex form has that minus sign in it. Remember what we do with the h that's kind of unique? We take the opposite of it. Well, same thing with p and q. Alright, so these numbers you just have to remember we are going to take the opposite of them. Alright, then the last thing to just keep in mind, A is the same A that we were using in the other form. So we still have that rule where if A is negative, it's reflected, which means it's going to be upside down. So negative A equals reflection. And the reason I write that down is because it reminds us which way it's going to open, and that's important because it tells us if it's a maximum or a minimum. Alright, so let's try an example in intercept form. So here it is, number 3, f of x equals 3, and then there are two factors, x minus 1 and x plus 2. So when you see two factors like this, that should immediately tell you that you know your x-intercepts. So I'm going to kind of jump down and figure out what those are first. I see x minus 1, I'm going to take the opposite, so negative 1 turns into a positive 1. So my first x-intercept is positive 1 comma 0. Alright, same thing with my next one, x plus 2, take the opposite, that will be a negative 2 comma 0. Alright, let's go ahead and plot those, 1 comma 0, negative 2 comma 0. Alright, now unfortunately in intercept form, that's basically the only thing you can figure out, aside from if you have a max or a min. So technically I guess I could look at this equation, see that there is no negative, which means it's a normal parabola, and normal parabolas look like the regular U shape. So I know I'm going to have a minimum. So I could kind of rule out the maximum part. But other than that, you really need your calculator to help you find the other pieces. So we are going to find our other pieces using the calculator. So vertex is going to be on our calculator when it's in this form. And let's try it. Okay, so take out your calculators. In my y equals, I'm going to clear out what I've got, and I'm going to type this new equation in. If at any point you feel like you need some time to do this yourself, just pause the video, right? Type it in, get it all set up, and then press play, and you can keep following along. Okay, so let's graph. And there we have it. There's our graph. All right, we see it's at negative 2 and 1. There are x-intercepts, so that makes sense with what we have graphed. All right, and then there's our vertex, and it's a minimum, just like we expected. So I'm going to find that minimum, second trace, and number 3 is minimum. And I'm going to do my left bound, and I'm going to do my right bound. And then we'll guess. And there's my minimum. Alright, now if you ever get decimals, not a big deal. Just round to 2 numbers after the decimal. And in this case, I don't really have to because there's only 2 numbers here. And these are a bunch of zeros, which is really just negative 0.5 then. So there's my minimum. Negative 0.5, negative 6.75. And when you're plotting this, if you did it right, you should have a minimum. Oops. That falls right in the middle of your 2x intercepts, but somewhere like up or down, further up or further down. So in this case, negative 0.5, negative 6.5. It looks like it's about halfway. I'm going to draw that axis of symmetry to double check. Yep, looks about halfway. So that makes sense. Alright, and now that I have 3 points, I can actually... Oh, that was bad. I can actually draw my curve. Oh, whoa. Sorry about that, jeez. Okay. There's one piece. And there's my other piece. Okay. If you were ever unable to get x-intercepts, not in this form, you would have to be able to get it in this form, but in another form, then use your table to get a few more points so that your graph is accurate. Okay. Alright, now that I have the vertex, I should be able to find pretty much everything else. Right, my axis of symmetry is that line I just drew. It's x equals, and then the x-coordinate of your vertex, since that's where it's going through. My local min is my vertex, so negative 0.5, negative 6.75. And that also happens to be my absolute min. Okay, now the y-intercept you could do on your calculator, but I also want you to just keep in mind that you also know how to do it by hand, because the y-intercept just means plug in x equals 0. And we could do that without a calculator if we needed to. Just to prove it to you, let's try it. So f of 0 is what we're doing. That's 3 times 0 minus 1 times 0 plus 2. Alright, that's 3 times negative 1 times positive 2. And that's going to be negative 3 times 2, which is negative 6. So my y-intercept is 0, negative 6. Now, if you have a calculator and you want to use it, that's fine. But if you see this on a non-calculator part of a quiz or a test, just make sure you know what to do. Alright, then everything else, again, I should be able to figure out for my graph. Increasing intervals, I'm going to use negative infinity, this value, which is negative 0.5, and positive infinity. Looks like I've got decreasing first, so negative infinity to negative 0.5 is decreasing, and then increasing. Alright, my end behavior, that's what's happening at the very ends of the graphs, those arrows, they're both pointing up, that's to positive infinity. And then last but not least, domain and range. Domain is left and right. I see an arrow left, I see an arrow right, so that's all reals, or negative infinity to infinity. Range, on the other hand, only goes as low as this point, so that's negative 6.75. Remember, that's from my vertex. So I'm going to say it starts at negative 6.75, and then those arrows are pointing up, so that's going to infinity. Alright, so it's a lot of the same of what we've already been doing. The only difference is recognizing the different form and knowing what you can do without a calculator. Alright, If you flip the page over, there's a second example for intercept form. If you feel like you need to practice it a little bit more, go for it. Try it, and the answers will be in the filled-in notes on Canvas, so you can always check there. Okay? Otherwise, in this video, I'm going to skip ahead. I'm going to show you one more example, but this time in standard form. Okay, standard form, just based on the name, it's kind of a vague name, standard, like that's not a part of the graph. And that should give you a hint that there's really nothing you can find from standard form. Standard form looks like this: ax squared plus bx plus c. So no parentheses. It's as though you multiplied everything out already. Alright, the only little tiny thing you can get from standard form is the y-intercept. And the reason you can get that is because if I were to plug in 0 for x to find the y-intercept, both of these terms would cancel out, leaving me with just c. So my y-intercept would be 0, c. Not very significant, so it's not that big of a deal, but it is something. And we still hold fast to that rule about negative a, right? This is the same a as in the other equations. So if there's a negative a, we are going to reflect it's an upside down u. Okay, so because standard form you can't really find much, we are going to be using our calculator for a lot of standard form. Alright, so let's get started. F of x equals negative 1/2 x squared minus x plus 6. Well, I see this negative for a, so in my mind I already know this is opening down, or in other words, reflected upside down. So to me, that tells me, hey, there's a maximum, not a minimum, because it's going to look something like that. Alright, so for my minimums, I'm going to say, nope, we got nothing here. Alright, but that's mostly it. I mean, we could find our y-intercept based on the c value. C is positive 6, so it will be 0, 6. But frankly, you could probably just plug it in and find that pretty easily too. So it's really not that big of a deal that you can do that without a calculator. Everything else we're going to use our calculator, so I'm going to go ahead and open mine up. I'm going to clear out my old equation and type the new one in. Negative 1/2, I like to use parentheses with fractions, minus x plus 6. And again, if you need time to type that in, pause, type it in, press play, go on as usual. Alright, so here it is. Let's find our vertex. It is a maximum here, that's number 4. Alright, I'm going to scroll over for my left bound. Looks good. Press enter. I'm going to scroll to the right for my right bound. Looks good. And then guess I'm going to press enter. And there it is, my maximum, negative 1, 6.5. Again, the zeros kind of give you a hint. Okay, we can just call that negative 1. So negative 1, 6.5. And that means my axis of symmetry is x equals negative 1. Okay, my local max and my absolute max are my vertex, so negative 1, 6.5. So the only thing left to do, besides maybe plot this point, negative 1, 6.5, is going to be to find my x-intercepts on the calculator. Go ahead and pause the video, and you can try it on your own, and then double check with me when you press play to see if you got them right. Alright, well, here are your x-intercepts. Pay attention to the rounding. It's really important that we're really good rounders, so we want to really practice that at the beginning of the year, so by the end of the year we're solid at it. So you should have gotten like negative 4.605. Well, that turns into a 6.1, and same thing over here. Alright, so I'll plot these right here and here, and I can draw my graph. Alright, most of the rest of the information you should be able to get on your own, so I'll just fill them in for you. Looks like it's increasing on the left, so negative infinity to negative 1, decreasing on the right. Okay, end behavior both pointing down, so negative infinities. Our domain, negative infinity to positive infinity. And the range, be careful, start at negative infinity and go all the way up to 6.5 with a bracket. And that's it. Alright, not too bad. So, the homework is on Canvas. You know how to get to it. Draw your graphs really nicely or use the same graph paper as you had for the last homework assignment. Otherwise, if you think of any questions, just write them down and I'll answer them for you later. Thanks for watching. Have fun with your homework.